Because while we are live.
Yep. I can start?
Yeah.
Okay, hi everybody. I'm very happy to be here with you on this Brain Hack event. My name is Vesna and I'm one of the founders of MintLabs. You guys, most of you met us yesterday. And today I'll talk about our journey, the journey in the company, but also in the imaging field that we've taken in the last, I don't know, 4 or 5 years, or maybe even 10 years if we count since the time of the PhD. So many people ask me, what is MintLabs? We are not a door-to-door delivery of mint tea, but we are all about the brain, something that we are all passionate about, and that's why we are here today and a lot of people around the world. And I can lead you a little bit how everything started, but I don't want to tell you just the success stories and to see how everything is flashing and how we are growing and everything is amazing, but I want to show you actually what it means to start a company and what it means to be in science and then start a company. So this is me in 2010. Actually, I'm an electrical engineer, that's my background, from Macedonia. And I did a PhD in Netherlands at the Technical University of Eindhoven in a group for image processing and visualization. And this is me getting the degree. Behind is Paul and another colleague who is actually joining our team in MintLabs starting from March. And you can see me happy, and you know, it makes a nice title. She finished successfully the PhD defense, but this is how I actually felt when I finished my PhD defense, and I think my PhD thesis, and I think many of you can relate. And I actually wrote it in my book, which turned out to be kind of a mistake because a couple of days before my defense, the dean called me and he said, "Oh my God, you don't write stuff like this." What I wrote is, I always wanted to write a book. I never imagined it would be this boring. I'm not proud of what I did, not a tiny bit. I just acquired knowledge in one very specific area, and I hope contributed for the future wandering researchers not to wander too much. Well, that's not a stuff you put in a book that afterwards will stay there and you have to handle it to people. But that's how I felt, and I think that many of the PhD students feel like that. We get into one specific area and then you finish your thesis and you're like, what am I going to do with life? I know about this, and what can I do? I can continue probably in academia, and most of the people continue in academia. Or when I was trying to find a job in industry, I didn't even know which keywords to put because I knew about diffusion, tensor imaging, and visualization, but what job can I find? And I did a postdoc, of course. This is one very important story for me. That is one of the motivation for starting MintLabs, and there is another story that is also important. So I told you I finished the PhD in Netherlands, and we were in this technical group where we were developing a tool. So we were coding. We were 3 programmers. Paolo was one of the 3 PhD students / programmers developing this tool for visualization. But we had very few data to test it on. Actually, data was super precious, and this was back in 2008 or 2009. So I was lucky enough to get scanned, and I had one scan of my head, and that was all the testing data that we had. So we didn't know anything about how to correct the data or which pre-processing step to take. We were just getting tensors and then rendering and doing tractography and beautiful images that when clinicians would see, they would be like, maybe you should do some corrections here, or masking, because we're seeing too much that we don't expect to see. So I was super motivated to find testers for my new algorithm. And so this is, I don't know if I can show, this is here Eindhoven, and Eindhoven had collaboration with the University Hospital in Maastricht. So we took our computer, desktop computer, with my colleague that we were writing this paper on some combined visualization of DTI and Hardy, and we drove for like 1.5 hours, 2 hours, and then we entered the hospital and we had finally end users physicians. And the funny story is when we tried to exit, the security was thinking that we were stealing computer. It was much easier to enter with a computer than to exit. But what I learned that day was that I've created, together with my colleagues, one of the most powerful visualization algorithms that exist. The visualization is beautiful, it's fast, but nobody would use it. And I'll try to show you some links. Now I don't know how it's gonna go with I have it here. I'll show you how this looked like. So just for you to get some idea. So we have we built this tool with VTK, Qt. We decided we're gonna make a plugin system. You all guys are geeks, I believe, and you know, from development point of view, was amazing. You can just code your plugin, and then you don't need to rebuild everything. But then from a user point of view, it was okay. We're gonna draw a region, load the plugin for seeding. Okay, now we're gonna do diffusion model, load the plugin for this. Okay, now we want to show the fibers, find the plugin for fibers, tweak some parameters. So when we showed this to the clinicians, they said, we love your pictures, but I'm not gonna use this interface. I have more examples of this, but I'm gonna go back to the presentation. So that was very frustrating for me, being a PhD student. And let's see, do you see my screen? Yeah. Being a PhD student, spending my weekends all the time coding, trying to publish papers and trying to develop this tool, and then hear from the end users that they won't use it because the front end is not intuitive enough. I think we all wanted to make a very nice tool, but to finish our thesis, we had to have image processing algorithms because that was our topic. So the tool stayed like that, and that was very frustrating for me, and I think for Paolo as an engineers, to put so much work into powerful algorithms that nobody will use, or maybe in 20 years some company will discover, and then they'll take some parts and then implement into their system. So going back to how it all started, let's see. Maybe switching the PowerPoint was too adventurous. I'll try to end the show. Let's see if this works. Okay. So when people ask us how it all started, from 2010, when we had the original idea, till about 2013 was a big no. So there was no success. We were pitching. We were two scientists trying to make, something, trying to start our own business, but we had very little background. Paolo did some courses in entrepreneurship, so he had much more knowledge of what to do than me, but we still didn't know how to present in front of investors. And presenting a scientific paper in front of your peers, in front of scientific audience, is very different than pitching to an investor. So everywhere we went with this amazing idea, they were just looking. First, they couldn't understand what we want to create. Second, they didn't understand how we could make money. And you should, by the way, have a look. I think on YouTube you can search how there are some comics on how Nikola Tesla is pitching to Silicon Valley VCs, how he can give free energy to the world. It's pretty funny. So it was situations similar to this. And everywhere we heard, no, this is not a big market. We don't understand what you're doing. And then in 2012, actually somebody spotted us, and this is not a very flattering image of Paolo, but we got a third prize in Barcelona in Premi Creatic, and this is the only picture that I can find from that moment. But I think that was the beginnings when somebody noticed that there is a value proposition to what we were offering. Actually, some of the other companies who won first or second place were a snowboard that you can walk. So you can see how easier it was to pitch that kind of ideas than to pitch an idea of advanced cloud platform for image processing and visualization. And then we incorporated the company in 2013. So it's Paolo and I and some of our first team members. This is Nicola, and here you see a little bit of Mark, and they're both still with us since the beginning. And then we started growing. So this is us. We were about 6 people. Landon is missing in this picture in 2014. 2015, we were about 10 or 11, I think about 10. And now, actually, we are 16 people. We just hired 3 new people joining our team. So things have been much better, but that doesn't mean that things were not difficult. All these years was very difficult, especially fundraising has been one of the most difficult and challenging aspects of starting your own company, and not having security. You don't know what's going to happen next. We are actually hiring. We want to scale the team. So if I'm not going to go back to Mint web page, but if you go into mintlabs.com, mint-labs.com, and then if you look at our team page, you can actually see some job positions. So I know that among you people here and also people who are looking at this broadcast, there are hopefully some people who are looking for jobs in this kind of environment. So feel free to send us your CV, and we need visualization engineer, scientific developers like neuroimaging developers, and a lot of others. And some of the ups in this challenging road were awards. We were selected as the best startup at South Summit. So we actually met some amazing people, like you probably spot here the prince back then, now the king, Eric Schmidt, and so it's been very, very interesting, to be between science and business in this field. And also, if you go to our webpage, you can register to receive newsletters where we not only share our success or which events we are attending, but also some scientific articles that we find interesting in the field. And hopefully, I'm very excited that in the next couple of months we'll share some big news. So register, and you will see what's happening. But I want also to talk a little bit what is all about, what is behind MintLabs, what it's really about. So it's about the brain, about this 1.3 kilograms of pink jelly that consumes 20% of the total energy produced in the body, but it takes only 2% of the body, and that has 100 billion neurons, which is 15 times more than the total human population. It's really fascinating to be in this field today. And one of the challenges, or why we're here, is how can we measure this so complex organ? And thanks to these different ways to measure, we've learned about, I think 2 days ago I read some blog from MIT, and we've learned more about the brain in the last 5 years than in the last 5,000 years. So that's thanks to all these new techniques. And if we group the techniques, there are a lot of different ways to measure the brain or to learn about the function of the structure. A lot of microscale imaging, something mesoscale, like clarity images, and of course in vivo images like MRI, CT, PET, and so on. And they all have benefits, or they offer different perspective on the brain, especially with respect to spatial resolution. So if you look at the single neurons, which are in micrometers, and some of the imaging modalities are in millimeters, like MRI, you can see the approximation that you're doing in the measurements, but it has the benefits that it's non-invasive, whereas when you want to go to more precise or spatial resolution, maybe you have to go with more invasive techniques. So they all offer complementary aspects, and we are living now in times of a lot of initiatives, a lot of data acquisition, in vivo, ex vivo, lots of projects, and towards the end goal of mapping the brain, or getting the human connectomes. What we do in MintLabs is more in vivo measuring of the brain, so techniques such as MRI, and in the near future we would like to also have analysis for CT and PET. And if we just look at this field, just in the last 30 years, a lot happened. I mean, if you look at imaging, maybe in the 70s it started with CT, MRI was somewhere in the 80s, but in the last more or less than 30 years we've been experimenting in vivo with humans, which is fascinating how much we've learned about the brain in such a short period of time. And when I try to explain what is MRI to broad audience, I know for you I don't need to say it with these words, but Niels Bohr said something, and I would like to quote him. He said, what these people do is really very clever. They put little spies into the molecules and send radio signals to them, and then they have to radio back what they're seeing. So with MRI you can take a lot of different, what we call modalities, like T1, T2, flare, resting state, diffusion, spectroscopy, and so on. But if you want to explain it to essentially to a broad audience, I think you can quote this. And each of these modalities, even within MRI, gives you different information about the tissue. So one of them is, and I think Paul also showed this yesterday, is T1, where you can see a good contrast between gray matter and white matter, and a lot of volumetric algorithms use this imaging modality. But also what we like is diffusion MRI. So when you create these beautiful images of the brain, and in diffusion MRI, what the signal basically measures, if we want to simplify it, is the diffusion of the water molecules in the brain. So the body and the brain is mostly composed of water. And if you look at just the diffusion process, if you look at this glass of water without, let's say, without straws, then the diffusion of the water molecules is random. But if you put some kind of a structure, like the straws, then the diffusion will be hindered by the structure. So by probing of the diffusion motions of the water molecules, we can know something about the underlying structure. So we will know that here, I don't know if you can see my cursor, here the molecules are moving along the direction of the straws. And it's an amazing phenomenon, and we are using this to create these beautiful three-dimensional maps of the brain, or what we want to call something like Google Maps for the brain. And this is what MRI allows us. And also what is absolutely fascinating is that it's completely non-invasive, so you can scan it over and over and over again. And then also with MRI, with fMRI, with functional MRI, we can know something more about the activation and more about the functioning of the brain. So basically, what we are measuring is bolt signal, increase of blood oxygen, and then we are looking at correlation. I mean, there are different techniques of how to analyze fMRI data, but we are looking at how different regions are correlated, or if they're lighting up together, and if yes, then that means that there is some kind of synchronous activities in these two regions or multiple regions in the brain. But also we are living in the time of the connectomics. So it was the Human Genome Project, and now you're hearing more about the brain initiatives, Human Connectome Project, also similar initiatives in Europe. And the connectome is in complete analogy to the word genome, where the OM emphasized the notion that the brain is a large and unique complex system, a network made of structural and functional connections, edges linking specific neural units, nodes. So I think Paolo also showed you a little bit of this, but if you want to construct the structural connectome, for example, you will need at least 2 images from the subject. You will need the structural T1 image to do the brain parcellation, and the diffusion image, and then once you co-register these 2 images, you can eventually reach a connectivity matrix and then use graph theory to analyze these or to do some population analysis. And then similarly, if you get the T1 again for the brain parcellation, and if you use the time series from fMRI, for example from resting state, you can have the functional connectome and again use graph theory. Also, you can use independent component analysis of the functional data. So there are different ways, and then you can see how the underlying structure is, related. There are different ways to go about analyzing human connectome data. A lot of technicalities on the pre-processing steps, and a lot of research happening in the field. And then when people ask us, well, you're a company, so you must make some money, and how do you make money, and who are your clients, and how actually you got initial funding, I thought it might be fun to show you what we do as a pitch in MintLabs when we talk in front of investors. So you get a little bit of flavor of the science behind how we started the company, but also what you have to do when you pitch in front of, for example, Silicon Valley VCs. So this is the typical pitch. A third of the population, a third of all of us here, will be affected by a brain disease. And unfortunately, most of the diseases are still incurable. So this is the problem, the pain that we are solving. And then is the money side. So this costs a lot of money to the governments of, say, both US and EU, and to the pharma companies, because to develop a drug, it costs them about $2.6 billion. But in the case of the brain and the central nervous system, most of the drugs fail. And I don't know how much you know about the clinical trial phases, but the way that whether a drug is working or not, depending on different stages of the phase, is mostly by looking behavior or making some kind of questionnaires. So say, I'm just making an example, in a drug for Alzheimer, they maybe will analyze the behavior of the mice or rat finding the food faster, or in a drug for MS or Parkinson's, the patient will be assessed every 6 months or every year, and then they will be asked some kind of questionnaires or clinical scores like motor score, CDSS score, or some simplistic tests, and then this all goes into some Excel sheets, and it's analyzed whether this drug worked or not. There is the placebo effect. There is a lot of in this whole system, a lot of places where things can go wrong. So these clinical trials can continue to more advanced phases and can cost a lot of money, and then they can fail. And we have a lot of these stories where a drug for MS in phase 3 failed, and it's the most expensive clinical trial that existed. You can read a lot about that. And imaging still has been used as secondary endpoint, even though, I mean, you're all in the brain hack event and you know about the image processing tools. Even though we have a strong community, we have a lot of research, we have a lot of image processing tools, still imaging, especially in MRI, has been underused. And then when people ask me what is MRI, sometimes I really have to say that almost every hospital has this kind of machine that normally sits in the basement, and it's like a fancy camera that takes black and white images, grayscale images of the brain. And then one of the problems is that when PAC systems were created, when imaging started, it's images. So what do you do with images? You look at them, and that's the old traditional way of using imaging. You're just going to look at the images, and then a radiologist will make a report, and it's still in practice. MRI scan is being taken, radiologist looks at the images, spots abnormalities or not, puts them into a report, and then that goes to a neurologist, or maybe in research, and in very few hospitals more analytics are done. But where it's pretty scary, now this graph is a little bit controversial. You can find 60%, you can find between 40 and 60%, but often specialists miss a lot. And often there is a lot of false negatives and a lot of true positives. The numbers are actually pretty scary. So we need computational analytics. In this field, almost everything in life moved forward, but in healthcare, things are moving very slow. And this was basically the motivation to create MintLabs, our cloud-based neuroimaging platform to accelerate brain diseases solutions. We offer powerful analytics on the data. We work with all MRI vendors, GE, Siemens, Philips, animal scanners. We have, using the cloud, unlimited scalability. We're faster and more accurate than any human can be, and we're HIPAA compliant. So, although today we said that the brain, has its own also fingerprint, but we make sure that the data that arrives to our platform is anonymized, so all the DICOM tags are stripped from any personal information. Our business model is the popular SaaS model, so software as a service. It has different tiers, different levels, so pay as you go. So basically, if you have a smaller project, you can pay per using the platform. But also we have subscription model for bigger institutions, and also different ways of generating, revenue from maybe sharing analytics and accessing to data. But what is very important is that we want to collaborate with people like you and with people in academia. So what we will be announcing more and more is how we are opening our platform such that you can port your tools. And then if you have a very good method that maybe you as method people, you've developed it in certain data, and then a lot of people worldwide are testing it, and they can test it in a very easy to use way, so they don't need to put the code, and then somebody in a very applied group has to find it on GitHub and then compile it and then have million problems and lack of support. You can put it on our platform, and then you have access to lots of users, and if pharma is interested, then we can find a way to work around such that you also can get, depending on your institution, different ways of compensations. Our platform has been up and running for 2 years, but we've in this period of time, and especially in the last year, we've done a lot of growth. At the moment, we have over 270,000 brain scans. We have in each quarter over 30% growth in each quarter of the year, and just in last year, and just in December, we had 100,000 revenue. We work with over 55 major centers worldwide, some top institutions. We are more than happy to collaborate with different institutions, so please, if you have some interesting projects or if you are interested, let us know. We work with pharma, with Bayer Pharmaceutical, and we've generated or created our IP. 2 different patents were filed just last year from some of the data and machine learning that we've done with it. And this is more on the competition. So what we normally want to say is that you see some big players, like putting Siemens or Philips as competition is pretty scary, but they're mainly the vendors of the hardware equipment. So they are generating the images that we analyze, and we are more IT company. And then you have more imaging markers, and with some of these basically spin-offs from university that are very specific in one area, they have a marker for atrophy or marker for MS. We actually work together in a way that we can offer them our cloud infrastructure, and they can port their tools that then can be used by pharma or different centers. We have an amazing advisory support. Walter Gilbert, he's a Nobel laureate in DNA sequencing, and he's one of the founders of Biogen Pharmaceutical. Chris Lewing, we cannot put, but he's a partner at McKinsey. Joe Fuller, he's a professor at Harvard. Pablo Viloslada, some of you might know him. He's also my former postdoc advisor. He's a professor at UCSF and also in a hospital clinic in Barcelona. Michael Fox, he's a professor at Harvard and Beth Israel, and Gary Robertson, who is our medtech and pharma advisor. And behind MintLabs, as I said, we are about 16 people now. We are growing our team pretty quickly. Check our page with new job positions, and if you think that you're fitting, or even if you think that you would like to be in this kind of, if you're not fitting in a specific job opening, but you think that you have some skill set that can add value to our company and you have the same vision as us, send us an email. And of course, we love cats, so we are a very cat-friendly company. And when you come and join our team, it's like we're like a big family. So we are very close. We all work in the same office space. We do fun stuff. Last year, before Christmas, we went on a paintball event. We celebrate the birthdays, and we are cooking. We have like a kitchen in our office, a big kitchen with an oven, and We are a very multidisciplinary team. We have people from Turkey, Macedonia, Portugal, from the States, Catalonia, Spain, Japan, UK. So people can cook their typical dishes, and then we celebrate birthdays, and we do fun things like mojito parties or escape room, and celebrate Christmas together. So it's really, we are like a family, and we're very close, and we really make sure that everybody who joins the team is happy in what they're working for, because like that you can really excel. I wanted to also share two projects that we have that are interesting, and if there are people who are looking for internships or master's projects, might be suitable. One is on the reproducibility of the different segmentation algorithms, like free surfer, ants, or like the combination of both. And another one is like, I will show you some images, and let's see what comes first in your mind, especially after this one. We like to also, we have a study on the entrepreneurial brain. So we were analyzing different psychometrics and also imaging data, such as extroversion, narcissism, psychopathy comes pretty high in the list of psychometrics, and we have this data available. We've done some preliminary study that we are going to show on ISMRM this year, but this project has a lot of potential and some more work, so if you are interested or you know students who are interested, this would be an interesting project. And I just want to finish with a sentence from one of our colleagues who is a co-founder of Neurolunch. If you're a brain geek, this is the best time to be alive in history. And I think we are pretty lucky people to be on this hacking event and to work with this amazing data and to be in this amazing field. So that's about it from me. These are different ways that you can get in touch with me and MintLabs. And I'll finish, I can take some questions, and I also want to invite Paolo to answer some of the questions if they're more related to, to his work. This is a visualization from our app BrainViz that is connected to another app that we have, Mojito, for upload. And yeah, feel free to ask me questions, and I can also, we are here, so you can pass by. We can give you a demo of how the platform works, how different apps like Mojito and BrainViz work, how you can use it. We have also, we are opening our platform, so you can also analyze some of your data. So just pass by where we are sitting, and we can talk more about it. And that's it. Thank you.
Thank you very much, Vesna. Thank you for sharing your work. Very inspiring talk. Does anybody have any question?
Yeah.
When you deal with security staffs, for example, it's a part in the business and startups, so important. How do you deal with that? Do you relegate these staffs from hospital or university, or you manage this?
I can partially answer, and then Paolo can answer. So security is very important. As I said, our app, Mojito, so we are HIPAA compliant, and the app takes care of all the personal information that stays inside the hospital, and only anonymized DICOMs are sent to our platform. We also have third parties that Paolo can talk more about, and also one of our investors, Chris Klaus, he actually founded a company, what is it, like 20 years ago or 15 years ago on internet security, so he's one of the advisors on that topic. But maybe you can add something.
Just to add that, so no personal information is uploaded into the cloud. So, and on the other side as well, the transmission is secure. And also the data location is very important. So it's in the cloud, so we have different partnerships with different cloud providers. So to make sure that data from Germany stays in Germany, from Spain stays in Spain, or Europe and US. So we have all these deals with different providers. So, yeah. So everything is like safe, secure, and transmission as well, because that's very important. Obviously, because it's sensitive information, it can be sensitive information.
Just out of general curiosity, what's y'all's exit strategy? So do you guys want to one day have MintLabs be shipped with every scanner from, I don't know, Siemens or Philips, or do you guys want to stay independent, or?
I mean, it depends. It's very open. We might go, so like an exit strategy might be IPO, maybe we can partner up with some of the hardware vendors. I think pharma company maybe would like to buy us. I don't know, there are different ways, and I think that now in the next 2 years is very important how we'll scale and how we will, better define our business model. I don't know if you have anything to add.
And also just a similarity, or for instance, IBM and all these huge and super huge data companies or informatic companies, IBM, Google, they are more and more also going towards healthcare. So for instance, IBM last year, I think, bought like a Merge Healthcare, a company that is was doing cloud storage of medical images, because there's this data. So what we're doing is data, but also the understanding of the data, right? Which for the brain is very important, because you're not just looking, even experts looking at an MRI, you don't really know if there's a disease or not. So there's much more there. So that's another possibility.
Have you guys done any clinical trials yet for detection of MS lesions and stuff, that are showing your platform as superior to what's out there?
I cannot really disclose, but we've been working in this field, especially in MS.
Okay, thank you very much. I think there are no questions online, so we can thank again our speaker.